Video will explain section 7.6 on functions. So first let's understand what a relation is. A relation is any set of ordered pairs. We're finding a relationship between the x variable and the y variable. The x is called the independent variable and the y is called the dependent variable because it depends on what x is. So if we replace different values into our equation for x, it's going to change the answer, or it's going to change what y is equal to. So here's an example. Let's state the domain and the range of the relation. Domain are all of our x values, so the first numbers. The range are all of the y values, our second numbers. And if we have duplicates, we only need to list them one time to say our answer is 12. We don't need to repeat it again. We only list it once. A function is a relation in which no two ordered pairs have the same first coordinate. No two ordered pairs, so no two points have the same x value. So what that means is if x is equal to -3, I can't have two different numbers for y. I can't plot a point that has -3, 4, and -3, -2. Okay, that would not graph a line. So we need to make sure that no two values for x are the same. So state the domain and range and of the relation and determine whether the relation is a function. So our domain is 2, 5, -3, and 1. Our range is 4, 8, 6, and -7. So what do we notice? Well, I noticed that a y here is a 4 and a y here is a 4, and that's okay because the x's are different. I can graph -2, 4, +2, 4, +5, 4. What is not okay is this 2. 2, 4, 2, 6. I cannot have the same x value with a different y value. So because of that, because there's two different ordered pairs have the same first coordinate, 2 of 2 and a different y coordinate, this is not a function. This would not graph. Here is an example. Begin by constructing a table of values. Graph x equals y squared. So I can say, well, what if x is -2, -1, 0, 1, 2? I replace all of those values in for x, get an answer, and that answer is my y. So now I have an x and a y. I have coordinates. You can plot all of these 5 points, and if you plot them and connect them, you get a parabola. Again, replace x with some simple values. We often choose whole numbers and choose from -2 to +2 as a way to replace our values with x to solve for y. And if I plot these points on a graph, we get another parabola that is going up. And you'll notice again our y is squared, so we're going to end up with a parabola again. And if I replace these values with y and solve for x, I can then write my coordinates, plot them on a graph, connect the points, and create a curved graph. We have what's called a vertical line test. If a vertical line can intersect the graph of a function more than once, the relation is not a function. If no such line can be drawn, then the relation is a function. Here are some examples. The parabolas that faced upward are a function because if I draw a vertical line, it only intersects one time. The one that we saw last that was facing to the right is not a function. 1 to 1. And why is that? Because there are two x values that have different y values, so that's not a function. A circle here graphed is not a function. The line passes through 2 times, again, our x value, and let's say fx is 3. This would be 3 positive 3 and 3 negative 3, and that is not okay. We can't have two values, two different values corresponding for x. If f of x equals 3x squared minus 4x plus 5, find each of the following. What would be the value if f equaled negative 2, if f equaled 4, and if f equaled 0? So we would replace f of x. So this is our x value. Replace x with negative 2 and solve. Replace it with 4 and solve, and replace it with 0 and solve. And we get our values of 5, 37, and 25. And that concludes section 7.6.